Me too. That's the best I've done on the 10
Well, today is 419. And I say this concludes the section of factoring. It's now going to be a long week or week and a half of preparing then for the quiz of all quizzes. And the quiz that's yet to come will have quadratics, quadratic lookalikes, cubes, difference of squares, grouping. It's a thing. So this will be the last, though, new skill that you have to learn so that we can then start to put all the pieces together. And you have to admit, if you've been working, that you already feel better about the cubes and the nested differences of squares than you did like 5 days ago. So, I mean, progress is there, and you'll feel the same way about all of this put together in about a week. Like uh, once we've put all the pieces together, it just gets hard because you have to now be able to look at a worksheet. Not today. Today's is all the same type. That's nice. But then at some point you have to look at this big worksheet and say like, oh, your cubes, I got to get a GCF. And then there's a big difference of squares. And that's a grouping. And that's a lookalike. And it's tough. So I'll just warn you in advance that it's pretty tough. But this is easy today, I think. But I'm sometimes not the best judge of that. So what we're learning today is the last method, and this is factoring by grouping. And again, I am often not the best judge, but I do believe that these are not bad. So I'm going to start you out with a super basic grouping problem. I'm going to try to find one that's, yeah, I think the easiest one on my list will be the last one, ironically. So let's start with this one. And if you want to know why we have to learn this, look no further than the question of what is this? And if you run down all the list of things that we've learned so far, it's nothing. It's not a quadratic trinomial, it's not a lookalike, it's not a cubes, it's not a difference of squares. Like every box that we would like to check as, hey, you're one of those, cannot be checked. We don't do 4-term polynomials, but 4-term polynomials, if they're going to be factorable, are usually factorable by grouping, which is what today is. And so I'll walk you right through the steps. Step one, as you know, is always find the GCF. And I picked this one first because I didn't want a GCF to be up in the way. But your job first is to look at all 4 terms and ask yourself if they have anything all in common. And they do not. There's no x's in common. There's no numbers in common. So we can bypass that step for this problem. But that will always be the overriding step one, is get a GCF if there's one. So since there's not one, now we're going to move to the next step. And the next step, you're really going to want to follow these steps very quite literally. The first thing I do is I draw a wall down the center like this. And what this does is it breaks the problem into 2 groups. So hence the name grouping. We have the group on the left, which is the cubic and quadratic term. And then we have the group on the right, that's the linear and the constant terms. And so what we're going to do is we're going to treat each group as if it were its own little factoring problem. And we're going to pull greatest common factors out of just the groups. This is not a holistic or global, I think is the term. This is not a global GCF. What I'm going to do is I'm going to focus only on the left side of that blue curtain. What is the GCF of just these 2 terms? So I'm going to take x squared and I'm going to pull it out. And I'm going to be left with what? Perfect. X minus 1. Bless you. Any questions so far? Okay. The next step in this process, and this one, I don't know why people ignore me on this one. It's so creepy. The next thing you have to do is copy the sign down that's immediately after the curtain. Before you even worry about GCFing and all that, just please trust me on this. Whatever sign comes immediately after the curtain, like in this case, you can see that it's a minus. I want you to copy it down to there. Always do that first. Now we can examine the terms themselves. The terms are a 6x and a 6. And what can I pull out of both of those? Very good. So I'm going to pull out, I already pulled out a negative by copying down that minus sign, and now I'm going to pull out a 6. And what's going to be left over if you pull 6 out of both of those? X minus 1. And the reason it switches to minus is because really now in hindsight, what did we GCF out of the right have? -6. And when you pull negatives, you have to do sign switches. And so the 6x is positive x, and then the plus 6 is now -1. Got it so far? Okay. And this is the part where I used to not explain why this works, and I felt really bad, and I've since fixed that. But do you notice something about the left side and the right side? They are. And if a polynomial is groupable, if it's factorable by grouping, it is not happenstance that this thing that I'm underlining and this thing that I'm underlining are identical. That means now that that becomes a common factor of the entire expression. So would you agree with this? I'm going to try to not lose you right now. Let's see. I'm trying to use the same colors, hence my pauses there. So I'm trying to match the format of what you see. And if you don't pay attention to this part, you'll never understand why this next step works the way it does. Would you agree in the thing that I've written off to the right, that if I said to factor that there is a greatest common factor of b? Okay, so would you also then agree, and please don't agree just to be polite, would you agree that if I said to factor the little thing over on the right, that I could pull a b out in front and be left with a minus c? Like you've GCF'd hundreds of times by this point in your career. So are we in agreement that that would be a fact? Okay, then what I want to do is take that thinking and I want to expand it over to the problem, the actual math problem on the left. Do you see how the white thing that I've underlined is common to both halves of the problem? I'm going to pull that out as a common factor, and my answer is going to be that common factor times that. And you should probably study that until that you really buy in. I'm going to draw a little arrow up here on the TV. Look at this green arrow, if you'd be so kind. And I really feel like you're ready to move on once you're ready to agree with this. The things at the ends of that green arrow, they say the same thing, basically. All I did in the bottom problem at the lowest part of the TV there is I pulled out the commonality of x minus 1, and then I rebuilt the other factor with the leftovers that I had. That's how you factor by grouping. Yes, sir? You read my mind. Yeah. And so that's why I picked this problem first, is because I didn't want that to happen on the first problem. I just wanted you to get your eyes on what it looks like to do grouping. Yeah.
The white thing on the board, will they ever factor?
The white one will not, but the red and yellow one will be. So like Brady said, if I had tweaked this problem just a little bit, then the thing that you see up there in red and yellow could have easily been x squared minus 4, couldn't it? And what would that mean? Difference of squares. So we'd have that drop step again where we got to go x plus 2, x minus 2. So again, that's coming. But any questions on just generally how to do grouping? Okay, you want to be real faithful with the steps. And let's do one more before we get into the GCS. Let's do 4x to the third, bless you, minus 12x squared minus x plus 3. I'm going to label these. So this one, I'll do it first. What's step 1? Before the curtain? Look for a GCF. And I'm just, even though again, I know there isn't one, I just don't want that to be something that we put aside. Like we always look, and if there isn't one, at least we looked. So now we're past that and we do what Bryn said, draw the curtain. And the curtain to me is, some teachers won't teach you to actually draw the curtain, and that's fine. To me, it physically cuts the problem into two halves. I like that. And now what's the next step? Right. I'm going to pull out the greatest common factor, but of only this left half. What is the greatest common factor? 4x squared. Perfect. And if you ignore the G, sometimes you guys have a tendency to pull out the CF. The G is going to hurt you here if you don't get it. Greatest is important. So I'm going to pull out 4, and I'm also going to pull out x to the second. What will my leftover be? Nice. Great job with your steps so far. What's the next step? Copy the sign, right? So that minus sign that's in front of the X, I don't care about anything other than just this. I need to take that sign and copy it down. If it's a plus, copy it down. If it's a minus, copy it down. That tells us going into the second half, are we factoring a negative or a positive out of the second group? What can you get out of X and 3? Nothing. And in math, how do we represent nothing? 1. Listen, I understand that and you're right. What we say, when someone says, what can you get out of it? Like, nothing. And that's a normal common thing to say, but we have to have a number here to build our factor. So I couldn't just put minus nothing and then start my parentheses. I need to put minus 1 and then put my parentheses. And, we normally don't acknowledge that we factored out a 1, like who gives a crap, right? But here we need him. And then what's left of my terms, the white terms? X minus 3. And listen, don't fudge it. Don't like BS it. If these two things that I'm underlining don't match, don't just change one of them to make a match. Go back and assess, why did it not match? Like, did I forget to change a sign? Did I not get a GCF in the first half? What did I do wrong? And they will match. Like, I'm giving you 10 problems on your homework today that will all work. And so if they don't come out like that, you did something goofy. Go find out what it is. Don't fudge it and just add a plus sign or something. Go look at it. So what is my answer then?
Minus 3. 4 squared.
Good. And as Brady very astutely alluded to, yes, what you see now is, now that we're comfortable with that process of, GCF, draw the curtain, GCF, blah, blah, blah. Now we need to be prepared for the fact that just like before, you're going to see those multiple levels of factoring. So there's more work to do, right? You see that difference of squares. I'm going to probably stop using red and yellow now because it's kind of annoying, but you do see him. What does 4x squared minus 1 factor into? Good job. Done. Good. You're welcome. So far, so good. Okay. There's really only one thing left to do that I can do to make this more difficult, and that is now to sprinkle on what we call a global GCF. So these problems haven't had global GCFs. We've just locally GCF'd the left side and the right side, but now I'm going to throw a layer of global GCF onto the whole problem, and it'll be our job to sift the GCF out, expose the actual factoring problem, and then do that. So that'll be what we'll do for these next 3 problems. You good, Pablo? Okay. So here in a few days, when it all starts to come together, what will be our cue or our clue to look at this and know I have to do grouping? I haven't explicitly said this yet. Why do we know this is grouping? 4 terms, right? So it doesn't meet any other criteria. Like, it's not anything that we've done. So when you see the 4-term polynomials, then you know that grouping is your guy. So what's step 1? No curtain. Got to get away from that curtain. Step one is always look for the global GCF. Like, is there a GCF that's all encompassing to this problem? The answer is, oh yeah. And I mean, I know at least this much, that I'm never okay with a problem starting with a negative. So I know I need to pull like globally a negative out of the whole dang problem. What else can I get out of the whole thing? I can get a 2. Good job. And yes, Sadie, I can also get an X. Very good. So pull out as much as you can, and then you'll expose the math problem that we want you to do. And the math problem I'll put inside of a set of square brackets, because I just want to separate square brackets from some round parentheses that are going to be popping up here in a minute. So what is my new math problem?
9x cubed plus 18 plus 4x plus.
Nice. You should be kind of used to that. I mean, I've talked enough about it that the GCF is really just there to throw you off the scent, right? So you peel that layer off, and you can now essentially throw that GCF and put him in timeout. I wouldn't really move him off anywhere too far, because we have a tendency, myself included, to forget that he ever existed. But what you need to do now is put the negative 2x out of your mind. And so now inside the white brackets, I'm going to draw the curtain. So my new math problem is now inside. Okay. Again, please forget the thing I've written in red. Ignore it. It's the GCF and it's on timeout. What is the GCF now of the left half of the curtain? 9 x squared. Very good. So I can pull 9x squared, leaving behind what? Nice. So again, focus. We're working inside the square brackets now. That's all we're doing. And then what's the next step? Copy down the plus sign, right? And so we're going to bring down the plus. And what is the common factor for 4x and 8? Good job. So we're going to bring down that 4, and then we're going to rebuild. And what's left over when we pull 4? Nice. So we're doing something right. So at this point now, and I don't mean to set a bad example. I just find with these problems, if I carry the GCF down, it tends to feel like it's in the way. So that's why I just, again, put it on timeout. Just don't lose sight of him. At this point, I'm going to build what the answer would be if there weren't that red thing up there. So what would my answer be at this point?
X plus 2.
And then what would we do? Yeah, what about, can't I factor this 9x squared plus 4? No, you cannot. When I said that, you were supposed to say, no, Mr. Ahern, those are squares, and we do not factor sums of squares. 9x squared plus 4 was a diversion. Don't fall for my games. All right, we could have factored it if it was 9x squared minus 4, but plus 4, dead. So at this point, I'm just going to do the GCF and go, whoop, copy him down, and say, game over. Done. Still good? Next one. There's 2 more, by the way. You get this? All right, sweet. So let's do 3x to the 6th minus 12x to the 5th plus 9x to the 4th minus 36x cubed. All right. Boy, step 1. This is the GCF of all 4 of these terms. 3x cubed. That was a good team effort there. That was everyone working together, all hands on deck. So we got the 3, we got a bunch of x's, and now it's time to rebuild. So here it goes. What's the first term? Second term. Plus minus. That's it, right? GCF. And as always, the GCF is out of the way, and now we can actually get to doing the problem. So the next step is breaking it down, draw the curtain, draw the wall, call it whatever you like, or don't draw it at all. But there he is. What is the GCF now of the left half? Twice. Which leaves behind what? Yeah. Next step. Copy down the plus. And what do you pull out of a 3x and a 12? A 3. Leaving behind what? What do we do next? Then what? Good. Again, I wrote these not to be nefarious, but like I wanted the x minus 4 to catch your eye, but only for an instant. Right? You saw the minus and the 4. That's a different. No, it's not, because there's no x squared. Right? So this is done. These are dead factors. And so the next thing is just bring down the GCF and put a big old box around it and pat yourself on the rumpski. Right? Last one. Oi, I am. What's up? Can I have like 2 more minutes? That'd be okay? You're welcome to come on in. Okay, thanks. All right, this will be our last example, and then it's worksheet time. What do we do first? GCF, which in this case is what? -2. That's the best we can do. We can get a negative because we have to. We can get a 2 because, well, it's there, but we cannot get any x's. So then we rebuild. What's the first term? Second term? Plus 6x squared. Next term? Minus 9x. And the last term? Thank you. And there he is, the math problem. So time to draw the curtain. Just like that. What is the GCF of the left half? Nice. Leaving behind what? Next step. Copy down the minus as a negative. And what do you get out of 9x and 54? 9. Leaving behind what? X, change the sign 6. Nice job. Pull that negative, switch the sign. And then you're like, boom, I must have done something right because those little bad boys match up. So the answer in its current state is see anything? Good. You're getting a lot better at this, guys, is spotting those cubes and squares, and great job. So that is definitely a difference of squares. And so we're going to go further. We're going to do x plus 6 times what? Nice. And then the final step is -2's up there screaming at you like, oh, forget about me. Bring him down. And then done. And you're welcome to keep the -2. What I have found over the years is I used to really struggle with when I and maybe it wasn't so much me as trying to communicate with my students, putting the -2 out here and keeping it around. I don't know why it feels like it gums up the works a little bit. So that's why I just keep it. And you're welcome to copy it at every step or just promise that you won't lose track of it. I don't care, but don't let that be why you miss it.
Like, merge it with that. You just entire.
Yeah, and that's why like I did it this way for a long time, is just keep the square brackets rolling, you know what I mean? Like just keep the square brackets rolling. However, whatever works for you. As long as like we all collectively agree that we get a final answer like that, then I'm a happy man. And how you treat that -2 from point A to point B is kind of your business. Good. So, all right, any questions? All right, awesome.